Um, okay, welcome all to the Astro Cafe for Monday, November the 10th. We've got some interesting topics, I think, today that we'll just move forward with. Um, Firstly, I should ask, is there anybody who has anything else that they want to put on the agenda today? Is there anything, any announcements or any other contributions that we can scroll to? Oh, yeah, Lori, go ahead.
Yeah, I'd just like to just do a little shout out for the FDAO and for the publications.
Okay, we'll go come to that in the announcements,
Come,
Lori.
yeah,
Is that
come later on. Yeah.
perfect? The other thing that we've seemed to have some success with in the last few weeks has just been new members or new people attending Astro Cafe. So as part of the new tradition, I'll just ask if there's anybody new attending today who'd like to introduce themselves and say a couple of words. I recognize most of the faces here, but anybody um, at the center there?
No one here. It's all
Okay.
here.
That being the case, we'll move right forward into the program then. I'm going to start sharing my computer. Can you give me a thumbs up if you can see the smart telescope slide there? David, do you see somebody see that? Okay, perfect. So I want to take a few minutes to talk about smart telescopes. Smart telescopes have been becoming increasingly talked about and used, and I just wanted to give you a little bit of introduction because they're new, but I think we're going to be seeing more of them. And even in looking into this presentation, the software upgrades change so quickly that things I was going to say about them actually is dated and there's more being provided in the smart telescopes than I was initially aware of. So, what are smart telescopes? They're not the go-to telescopes that have been around for a while. Instead, they try to define smart telescopes a little bit more narrowly. They're self-contained optics with built-in computers and digital sensors rather than eyepieces. They come with a software app, which can be used usually on a phone or an iPad, or any other type of device for setup, navigation, object tracking, and image stacking. And that's usually part of the software package embedded in the smart telescope. Theoretically, they produce clear views of the sun, the moon, and deep sky objects. Because of the nature of the smart telescopes, they're not at this point great at imaging planets because there isn't a lot of ability to get that degree of detail in the image. Um, Certainly, as the software improves, it certainly may be possible to do better imaging with the planets. Smart telescopes started in about 2017. The first offering that I could find was from Unistellar. It was called the Odyssey. It's the one on the left. It was actually made available in 2020, but as I say, it was developed in 2017, and it was marketing for $3,500 at the time. Vaonis, which is a company in France, was next on the market with Stellina, That came out the next year in 2018, and it was being marketed for $4,000. So these are, certainly smart telescopes, but beyond the means of many people doing stargazing. And as you see, as we get through this, as we get into this, I'm going to start concentrating on the less expensive but better known smart telescopes that are on the market these days. Please take everything I say with a grain of salt, because as I say, the upgrades are happening so quickly that it's almost, well, it's difficult to stay on top of what's being offered and what's actually on the market at this point in time. So you have to kind of try to change this so you can see it. Wrong way to change it. There we go.
It looks fine, Jeff.
Yeah, it was blocking out part of the text, which was going to block out some of the pictures in another slide or two. So smart telescopes are essentially camera lenses, and they project an image onto a digital sensor. Magnification is expressed as a focal length, usually with a 35 millimeter focal equivalent, which gives you an equivalent focal length. But they will quote the original focal length of the objective lens as well. The user views the image on a screen, and it's usually an iPad or some other optical device like that, where the final magnification can also be changed depending on the screen size, the viewing distance, and whatever digital zoom you want to apply to it. The scopes that I'm going to talk about mostly are the Sea-Star, the Dwarf, and the Vespera, and for reasons that we'll come to in a few minutes. All of them use apochromatic multi-lens refractors. The Sea-Star 30, which is a newer product, is a 2-lens system. The 50 is a 3-lens system. The Dwarf 3 is a 3-lens system, and the Vespera Pro is a 4-lens system. But basically, the lenses themselves are used to focus the light, minimize the chromatic aberration, and sharpen up the image. When you get into the definitions, and everything becomes a little bit, there's boundary issues here. They talk about the Dwarf 3 and the Sea-Star 30 and 50 as using telephoto lenses, but the Vespera using an advanced refractory system which simulates telephoto lens. But essentially, they all produce images in a similar way. This is the Gainor Vespera. Both the Vespera 2 and the newer, more expensive Pro look the same, so I didn't get different photos for them. The Vespera 2 was released in 2022, and the Vespera Pro was released in 2024. And as I said, that's a company in France. The ones that perhaps you know most about are the Sea-Star. It's a Zuo product. Zuo is a product coming from China, which is serviced in the States. The Sea-Star S50, which was the first out of the box, was in 2023, and it seems to be quite a powerful smart telescope. The Sea-Star S30 came about with certainly some refinements on the 50. Also with a lower price tag. They marketed it to make it more accessible to the market. It was released in 2024, and it's also, of course, because it's a Sea-Star by Zuo. The competition to those scopes is the Dwarf Lab Dwarf 3. Dwarf Lab works with tiny photon technology. It's a Hong Kong company. It was released in 2025. The Dwarf 3 wasn't the first on the market. Dwarf 2 came before it in 2023, but it's been supplanted by the 3. I don't think that Dwarf Lab is marketing the 2 anymore, although it's available from some retailers. This is a very busy slide, but I think it's important to see it so you can see what kind of things make up the smart telescopes. I'll walk you through it because I thought there were some interesting points. The other thing to see is that the scopes are really very similar and produce the very similar results, um, with certain variations relying on different things. So you'll see that the apertures are usually either 30 millimeters or 50 millimeters. 50 obviously is going to be better for light collection. And I won't walk through each one with each bit of information, but the C-Star 30 is a 30 millimeter, the 50 is a 50 millimeter, Dwarf is a 35 millimeter. Vespera is 50 millimeter for both of its offerings. Focal length, which certainly has some impact on the image size, but not the sole factor on image size, is between 150 and 250 millimeters. They're all about f5. The Dwarf 3 is a little bit faster at 4.3. They all use different sensors. The sensors are chosen to fit the scope and the focal length. The sensors are the part of the scope that has the pixels. So the pixel array is part of the sensor, and they're set up slightly differently, but provides a similar function. The resolutions, this is where things start to differ. The C-Star offering was an HD type resolution with roughly 1,000 lines horizontally, which makes it an HD. The 4K, which is similar to television sets marketed now, the Dwarf 3 and all of the Spear offerings were 4K. With an upgrade, the C-Star now offers 4K also through a little bit of sort of technology upgrading. Pixels are all roughly the same size, between 2 and 2.9 millimeters. It's interesting with the different focal lengths, you get different fields of view, and just so you get a sense of the importance of the field of view. Some of the things we image, the Orion Galaxy, for example, is 1.4 degrees. Andromeda Galaxy is about 1 by 3 degrees. And one of the focuses of these scopes is in imaging deep sky objects. So if you have a limited field of view, your ability to visualize and image some of the larger deep sky objects is a little bit restricted. But again, technology is changing that, as I'll show you. But basically, the field of views, vary from the C-Star 30, 1.2 by 2. The 50 had a little bit narrower field of view, although it's been able to expand that with some technological developments. The Dwarf is about 2.9 by 1.7, and the Vespera similar. The C-Star, when it came out, was only in Alt-Az. It's upgraded with the software to equatorial mount as well, so it can track in both manners. Same with the Dwarf 3. It's always been both Alt-Az, and you can set it up as an equatorial mount. That's with a wedge. Vespera, as far as I can find, is only offered as an alt-azimuth type of setup. The battery lengths, vary, but you can put a power pack on it. So I didn't find that the indication for the battery length was that important. Storage at this point anyway, the Dwarf 3 is 128 gigs, and to do much repetitive imaging, you do need a 64 or 128. And you do just need to download it and get it off the scope. I didn't see, certainly the Dwarf doesn't have the ability to take an external stick. I don't think the C-Star does. I don't know about the Vaonis. One of the real appeals of these scopes is the weight. They are quite light. As you can see, the Dwarf is 1.3 kilos. Vesperas, which are the heaviest, are 5 kilos. Then the final factor is the price, and this is from a recent site in England. I converted the prices there to Canadian prices. So they're roughly $1,000, but the onus or the Vespera offerings are quite a bit more expensive. The optics are better, and as you'll see, they come with less. Just to validate the cost, this site talked about the Dwarf 3 as being about $965. I purchased a Dwarf 3 earlier this year, and this was the price with customs, so it's $999 for arrival at my door, and that's Canadian dollars. So you're left with, you know, different scopes are slightly better at different things. And I think that the Vespera imaging is probably a little bit better because of the better lens system. So the C-Star 50 with a 50 millimeter aperture has better light gathering. A sensor is small, 2 megapixel resolution. It can now achieve a 4K resolution, and the technique they use is drizzling, which slightly alters where the sensor is focused, so it moves it a little bit. So you get a larger image. Field of view. The Mosaic allows the telescope, the smart telescope, to do the same imaging on a second field. So you can basically double the field of view, which is how the C-Star has upped its field of view to 2.5 by 1.5. The downside of Mosaic is it takes twice as long because it'll repeat the same imaging in a second field of view and then combine them seamlessly. It doesn't. The 50 has an equatorial mount or an equatorial function when used with a wedge. It provides a 40 times optical magnification, which is pretty good. And then there's the digital magnification that can be applied to that. I'll just skip down to the Dwarf so I don't prolong things, but you can see the similar information about the 30. The Dwarf 3 with a 35 millimeter aperture is smaller, but it does have a much more robust sensor. It's 8 megapixels. It provides, it has 2 distinct lenses, a wide lens and a telephoto lens. It'll provide HD resolution with the wide lens and 4K with the telephoto lens. It's got a pretty good field of view in the wide angle, which can be used as a spotter scope. As I'll show you some views through the imager, where you can actually find something and then go to the telephoto lens with it. Equatorial mount. Its optical magnification is only 29 times, so it relies on digital zoom beyond that. Similar information about the Vespera. This is only the Vespera 2. Robust sensor. It's got a fair-sized aperture, 50 millimeters, good focal length for enlargement. And interestingly, the Vespera only has a very limited storage, and I don't really understand why, but I suspect that'll change with upgrades. So when you get down to the C-Star, the Dwarf Lab, and the Vespera, all allow manual settings, in-app stacking. So it stacks. Certainly, the image stacks. You can visibly see the image stacking in the viewer with the Dwarf. I don't know about the others, but I suspect it's similar. The individual shots can be shot in RAW. They can be exported for integration with other stacking software, such as PixInsight, but it also has a program built into the smart telescope itself. The other thing has to do with the pixels themselves, and again, pixel the arc seconds that the pixel shoots. You want to find a balance in that. depending on what you want to image. So because these scopes all are primarily used for deep sky objects, the optimum pixel shoots or is a one to two arc second spread. So that's the degrees that the pixel will view for the light. If it's too wide, there's a lot more noise. If it's too narrow, then you're shooting much smaller images. So if you want between 1 and 2, most of them are over 2. It's only the Vespera Pro that has an actual proper sized pixel for deep sky imaging. It's a little technical, and all of the scopes try to manage that oversight with different built-in technologic adjustments. They all come with filters. The Dwarf 3 comes with just a visible light filter, which is automatic. You can substitute in an astro filter or a dual band filter. The dual band filter for the Dwarf is actually a triple band filter. It's oxygen 3, hydrogen alpha, and hydrogen beta. There's also a sun filter. The sun filter is applied manually. And that's really the same situation with the C Star. It does it a little bit differently. It's got the daytime filter, UV and IR. It's got the dual band, which is a true dual band with the C Star for oxygen 3 and hydrogen alpha. It has a dark filter which you can automatically switch in to take dark frames. I didn't mention it, but the Dwarf relies on a manual means of taking the dark frames. You need to put on the solar filter and then rotate the lenses into the smart telescope itself to take the dark frames. The C Star also has a solar filter which is applied manually. Vespera, you can't get any or you can get filters, but nothing comes with the smart telescope itself. They're available for additional purchase. So just an example, the Vespera and the Dwarf do come as a package. The Dwarf comes with a carrying case, the magnetic solar filter, the built-in filters, a USB cable, and so on. The Vespera comes also similarly equipped. Vespera, I think, comes with a small tripod. The Dwarf has a small tripod available for additional purchase. So, smart telescopes provide magnification through telephoto lenses. They're not traditional telescopes because they don't have eyepieces. There's no eyepiece swapping. So you don't have an ability to change field of view or magnification with an eyepiece. It's done quite differently. There's a fixed focal length, digital zoom to adjust apparent size of the image. Because the image isn't 35 millimeters size, it's cropped. So you can get an apparent 35 millimeter focal length, which is also a term you'll see provided with the smart scope. The scopes are not designed for high magnification planetary viewing at this point in time. Deep sky astrophotography and also other photography, land photography, and as I'll show you, the Dwarf has several other features that make it useful for other types of imaging. This is the Dwarf 3 on a tripod. It comes with two lenses. There's the wide lens and the telephoto lens. This is the Dwarf with the solar filter applied. It's just a magnetic clip-on. It applies easily and unclips very easily. So in terms of the applications, the Dwarf has both a bird tracking and an animal tracking sensor on it. This is my brother's setup in Just outside of gee, where is he? He is just outside Vernon. He has a setup. He's an entomologist by training, so he's got a lot of setups for viewing the animals there. So I'll just go back. So this is a setup for his bird feeder. I won't do this at length, but it'll capture the bird. This is a spotted towhee that frequents his place. So it keeps the image nicely centered, is the point I wanted to make with that. This is his hummingbird feeder. This is one of the rufous hummingbirds that come by frequently. Again, it keeps the image nicely centered. There is with this a similar tracker for what it calls UFO objects, so moving objects in the sky. I haven't yet tracked to see how fast it'll follow them. It follows birds in flight at a certain speed, but certainly not with the fast random changes of direction. So this is what the Dwarf 3 app looks like. When you turn it on, there's a designation for photo. And there's some settings here for when you want to do the dark frames. When you go into the photo app, you can choose different types of photography. It will also shoot video. The round circle designates that it's been chosen as photo. These are the two lens systems. This is the wide angle lens, and the square in the center will give you the what you're viewing with the telephoto lens. So as I say, you can use that as an imaging scope. You can make one or the other lens disappear. You can bring the wide angle lens to the front for a more robust picture. This is now in the astrophotography mode, so this is for stacking. It'll stack the image in real time as the shots are taken. So this is one of the views of the sun. You can see it's processing at this point. This is now stacked 60 of looks like 325 at this point. It'll stack up to 999 photos. And this is the final image of the sun with that stacking. This was a stacking of the sun I did at the Saanich Fair. So it's quite a good image. I've subsequently learned how to focus it better, so I'm hoping future shots will be even sharper than that. This is a photograph I did at the Saanich Fair. This was interesting. The photos come out in white, and I worked with David to just change the hue so that it came back to the similar type of picture with a stacked image. This is the photograph. You can see that the photograph itself is not as sharp as the stacked image was. This is looking at the moon. It's got a specific moon tracker as well. The image was good. I'm working on it, but it gives a pretty good image. And I think this was in a twilight sky. This is the photograph. You can see it's much sharper as a stacked image. And then I started playing around with just a little bit of sort of interesting looking pictures. So this is in the clouds. This was one of the moon shot from Quadra. These are some sunset pictures, and just again just playing with it to see what kind of imaging I could get. So these would be one shot photographs. These wouldn't be stacked. This would be on a photo image. So then I became interested in trying to shoot some deeper sky objects with as you see, some limited success. This is of the Ring Nebula, just along the base of Lyra. So this is actually the object I'm trying to shoot. I did use the internal software to clean the image some. But again, I need to get much sharper image, and I need to get it so that I can magnify it much more than that. So TBD, we'll see. And this was my first attempt at the Andromeda Galaxy. This was just 42 images because there were some other problems that limited that view. So that's a brief introduction to smart telescopes. Any questions? Any thoughts? Hey, Lauri, go ahead.
I was just going to ask, what is going to be the possibility that you're going to buy one of these and like within 6 months, it's been, updated so much that what you've bought for, $1,000 or so is then now going to be kind of a bit out of date. Like,
It's a really good question. You're talking about hardware upgrades, and most of the upgrades that have occurred so far have been software upgrades. So I've had 2 software upgrades since I got it. I got it a few months ago, and you get a note that there's been an upgrade. Upgrading is very simple. You hook it up through the computer, and there's a way that you can hook it up to the computer and to your home Wi-Fi. So I don't think that's going to be a real issue, Lauri. I think more it's going to be the software upgrades. I'm sure eventually, hardware itself will change. But as I said, most of the changes with the Sea Star, including the ability to shoot wider field and to improve the resolution, were all done on software upgrades. It had nothing at all to do with purchasing another scope. But it's a good point always, with technology, when is the hardware itself going to require, or when is the software going to require different hardware?
If I could help answer that.
Yeah, go ahead, Ben.
I don't know if I'm on the camera, but yeah, I think the cameras is really the most of what you're paying for is the camera technology, and that's right up to date. They're modern cameras. If you want to get smaller objects in the night sky, you have to actually get a larger telescope. So the upgrade would be a larger telescope, and maybe these smart telescopes will evolve to handle longer focal length telescopes. But then you're paying a lot more for the telescope instead of the camera, if you know what I'm saying.
Yeah, so you see that as a fixed limitation on it, rather than technology being something that improves resolution.
Well, you're getting the most modern camera technology
At this point.
on a smaller scope, and that's actually the beauty of it, is that you can take it anywhere very easily and take your images, as opposed to hauling around a big scope. If you haul around a big scope, then you use the same camera, but you're paying a lot more money for the telescope and the mount to hold it, if you know what I mean.
And sure, and you certainly lose the advantage that you paid for.
Right. If you're interested in getting a telescope, if you go to, it's an astrophotography website, it's astrobin, astrobin.com. And if you just, it's free to browse on that website. If you just look for the telescope you want, you'll see other people have used that telescope to take various deep sky objects. And you can see what they look like, and that's pretty much what you'll get too, if you get that telescope.
Is this a purchase site or just looking at the kinds of images that are produced?
It's purchased if you want to post to it, but if you just want to browse what's on there, it's free to look at astro images.
Interesting. Ben, did you have a comment?
Yeah, I was comparing, I'm sure just like everyone else does. I could see why you got the dwarf tree because that seems like the best bang for the buck. I don't know if that's what you based your purchase on, but that's what it seems like to me. But I also noted that you got it from England. Do you know if there's a Canadian?
It was the price comparison was England. I was looking for some site that gave me a comparison of all the prices. That's the only reason.
Okay.
I purchased directly from Hong Kong, which seemed to
Oh,
be
okay.
the only place to purchase from.
Oh, okay. So what was that site that you purchased it from?
Oh, it was Dwarf Lab.
Okay.
You know, I'll look, but I think it was dwarflab.com.
Okay, makes sense.
Yeah, and the reason I purchased it was just the versatility in terms of the different type of imaging. I also like the idea of having a spotter scope, which I think the other ones don't do quite as well. You don't have a two lens system, so you don't have an ability to have a wide lens and a telephoto at the same time. That seemed a little bit more telescopy to me, and I like to, rather than pushing a button, I like to be able to find where I'm going to.
Yeah, I noticed that. That was good.
David.
Yeah, one comment I'll make is that it's pretty hard to reproduce all the stuff that the smart telescope can do, but it is limited. I think that its one advantage is that, when the rest of us, when we've bought, full-size telescopes and bought filter wheels and things, they're like 2-inch filters to sort of future-proof ourselves, against additional equipment. They get to use tiny little filters. So they're a fraction of the price. And the other thing is that they get to put things in a chassis, which is all integrated as well. I tried putting one together myself just with my own components, and I wouldn't be able to duplicate the speed at which it would work. I can duplicate the optics, but probably at probably 4 times the price, at least the optics that I'm using. And then the sensor, well, they're very modern sensors, as David says. Like I noticed that one of them has a 585. That's a totally up-to-date sensor. So it's not going to have any amp glow. It's modern, right? But as you notice, they're smaller. They tend to be smaller unless you're into the more expensive ones, which have the larger sensors. But all in all, I would say they're a pretty big bang for the buck. If you're not expecting to make big murals with them, I would say they're excellent.
Absolutely, and they're certainly not the be all and end all. With anything, there's pros and cons.
Mhm.
There's things that it doesn't do, and there's things it does quite well.
But I think they were really smart in the marketing because they were able to give us similar things that we would do with more expensive rigs, but it's all miniaturized, so everything's cheaper. Smaller filters, smaller sensors, smaller optics, but
Okay.
they still do the job, right?
Well, for outreach, they're really good because I saw one where all the participants could stand around the telescope, and on their own, the camera would broadcast the image to everyone's personal phone.
Oh, that's interesting.
So at the end of the day, at the end of the session, people still had those pictures on their phone and they could take them home.
Yeah.
And that was sort of like very engaging.
Mhm.
for participants in outreach.
That's interesting. It's interesting concept with the dwarf. As far as I can see at this point, you need to have the software package downloaded on my iPad or on my phone, on my iPhone, and I can certainly then with the final product share the image. But that's like sharing, a photo. It's an interesting idea to be able to have the image appearing on different portable.
Yeah, device.
That's interesting. Um,
Jeff?
Chris, did you want to say something?
Sure. Well, I'm the owner of a Unistellar,
Oh,
and
no kidding.
which I got about 3 years ago, and then very shortly after I got it, I had a kind of a bout of health issues. But um, uh, I've really found your presentation quite interesting, because a lot of things are similar. It is really great for deep sky work. Not always. I've looked at some planets, not very good at all. Um, uh, I get software upgrades, and after a couple of upgrades, I've been able to get some not half bad, not fabulous, but not bad images of the moon. But yeah, I'm still, fiddling around with it. Um, Sometimes it's quite good, and sometimes it's not so good. It works. It works with your iPhone. I'll and Sometimes I've had frustrations setting it up. But anyway, it's interesting, and I'm someone who's not had that much success over the years with astrophotography, but yeah, I'm getting some bang out of it. I forget, I was able to get one reason why I bought it when I did was that I think they were about to upgrade the model or something. So I was able to get quite a good deal on it.
Chris, did the Unistellar come with different filters? And were they built into the package, or were they sort of manually applied?
Uh, Not that I know of. There's no filters that I would have to apply, and there wasn't really any discussion that I can think of about the filters. Uh,
There was no mention when I was looking into what were the early smart telescopes. There seemed to be no mention of filters, so that's why I was curious.
yeah, but yeah, compared to the scopes you were talking about, I think the Unistellar is fairly bulky. You know, uh, which is why I didn't take it to Australia with me. But perhaps if I had one of those ones you were showing, I might have taken it with me.
Interesting.
Jeff?
Yeah.
Here. So I'm going to ask a question which is on purpose provocative, but is it fun? And do you get a sense of accomplishment when you produce a photo with a smartphone? Because I really am having a bit of trouble with the idea of having the machine do all the tricky stuff that makes the final product of astrophotography, gives one a sense of ownership. I'm thinking my son always makes fun of me because he says, who's got a good camera? NASA. He doesn't understand why we do all this stuff. And I think
It's a really good question, and it's part of that debate. I'm sure that you guys had those debates with the go-to scopes also. In that, it's yes, I have fun, but you want to also know the sky, and the concern is, does it allow people to just push a button and get a picture, and you know that that's not going to have much staying power. So I guess the answer is yes and no. One of the things I found appealing, as I mentioned, about the dwarf was you actually have both a wide field and a telephoto viewer that you can use at the same time, so you can actually image where you're going to a certain extent, because there's limitations because you can't change the magnification, but you can view where you're going, and then you can cone in. But deep sky objects that are sort of, eighth magnitude, you're not going to find anyway. You can find the general area of the sky. So it's a really good question. I suspect that question
And
is
I
going
found Dave's answer really compelling, that you can then in outreach get a bunch of people together to have that sense of ownership. They were there at the time these photons were being collected. That totally drives me.
Yeah.
I'm thinking, just when I'm out in the night sky, I know that a lot of people are doing it, but it's not computing in my head. But maybe I'm too
It's a
old.
very personal question.
I know.
Because, you've got astrophotographers out there who are artists, and they love to, they're obsessed with me. I like to know what is this thing and how does it work, right? And other people are, right, it's all so personal.
Yeah.
And then you got observers who say, I'm not really interested in astrophotography at all. I want to see the photons in my eye. And you get, it all depends on.
Yeah, I think that's a good answer, and Randy, that's a very good question. I sort of think about that too. Because with this unistellar, there's still a certain amount of head banging involved. So I do feel like I've achieved something, but compared to what some of the other folks in this meeting can do, it's 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 uh it's not very impressive, but at least I did it. So uh with all this machine help, admittedly, and it's kind of like, it's a little um souvenir of what you've done. Some people are just content to look, some are content to draw it. Um, if I have a talent, maybe it's writing about it. Um, uh, but and and it's not photography. One thing I will note, uh, I thought was interesting is, when we had that comet last year. I forget which one it was, but a little over a year ago now. Um, and and a number of us imaged it, and the image I got was actually somewhat different from what other people got. So I thought that was kind of interesting, and so I kind of, like, I featured it on my Zenfolio page. So anyway, but yeah, I'm not going to, I'm not. Uh, I I'm very impressed with the work that a lot of you other people have done, and I'll leave it there.
David.
Yeah, I think Randy has a good question, and I think really the point of engagement is so varied, right? Like I enjoy the chase. That's what I enjoy. Whether I get it or not for a particular event, that's probably not as important, but I appreciate the chase. And the weather can be so variable, so you never know what you're going to get. The conditions are so variable, you can never exactly nail down what you want, right? So I don't know. That's the excitement for me. I mean, I think the resulting image, if there is one, is fun, but it's a memory thing for me. I think it's the event happening that's what's exciting for me.
Interesting. Anyone else? Any other reflections on the
Yeah.
appeal of?
Reg at Fairfield.
Yeah, go for it.
We've had a couple of rascals bring their C-Star 50s up. And what I enjoyed was kind of vicariously watching their sense of glee as the stuff magically showed up on their phone. And they were really having a lot of fun.
Yeah.
And it was fun without the speed bumps, the technical speed bumps that a lot of people go through. And I think that's kind of it's kind of a neat thing. It's almost like it's quite satisfying to solve technical challenges. And it's kind of the difference between being a mountaineer and a mountaineer that uses an escalator to get up to the top. They don't have quite the same feeling for it. But the one scope that's a bit bigger is the Celestron Origin. And I was wondering if you looked into that one at all with that in your studies.
I didn't look into that at all. I wasn't even aware of the Celestron Origin. So no, I really tried to restrict it to most of the information to the scopes that are under $1,000.
Yeah, well, the Celestron Origin is a 6-inch diameter RASC scope of 2-inch, 2.2, a very fast scope, f2.2. The downside of it is, one, the price is up there. And the other thing is it's not light anymore. So these guys had such gorgeous carrying cases when they brought their scopes up for the VCO. It was just ideal. So there's kind of when you go to a bigger scope, you lose that portability aspect of it. But it's a great new era as far as I'm concerned.
There's no substitute for a big scope. Like there's no technology that's gonna mirror, and that's why you can't take planetary images, is because you need a big telescope. But that's life.
Interesting. Yeah, the multiple trade-offs with the different types of imaging. That's interesting. Any other comments about scopes before I move on? Okay. One of the things we've been watching, in the last year or so has been the gearing up to Artemis 2, but that's been in the face of big cutbacks in NASA and then playing with who's going to be the new director of NASA. And if you remember, there was a projection of Artemis 2 is going to lead to Artemis 3, which was hoped to lead to the Gateway, which was the orbiting station around the moon, which was going to potentially lead to Mars. But now Mars seems to be more Elon Musk's thing. Anyway, I was uncertain where the manned space program was at, so I asked Chris Gainor if he could just reflect on where things are at now. Chris, are you able to talk to that?
Okay. Just a minute here. Okay. Got a couple of slides here. So I will share them. So a little update. Last week, I was speaking about my visit to Australia and going to the big International Space Congress and seeing Sean Duffy, the acting administrator of NASA there, and talking about the speculation about him being interested in being the administrator of NASA, and also the rumors that Jared Isaacman, probably the world's premier private space astronaut, might wind up having the top job at NASA. So that was a week ago, and I think the next day, I got word that that President Trump has um, restored Isaacman's nomination to be head of NASA, because you might recall, even before he became president, he nominated Isaacman for this job, and um, and then and it was going through the Senate. It was almost through the Senate for ratification when it was withdrawn, and this took place at the time when Trump and Elon Musk were having their parting of the ways, and but it was a bit more complicated than that. There was a person inside the White House who's in charge of vetting these positions, and he decided that Isaacman was insufficiently loyal to the president because he had in the past donated to Democrats, and and was associated with Musk, who was all of a sudden not the big person he was in the eyes of the Trump people. So Isaacman kind of took this, in a very laid back fashion, I guess. He didn't badmouth people, and basically kept his nose clean and talked about various things, and said he was honored to have gotten the original nomination. And so a few months have passed, and now he's back. So just with any luck, especially now that the government shutdown seems to be getting settled, there's a chance that he might be in charge of NASA by the end of the year. So we'll have to see. But just a little bit about this fellow. He's a kind of a .com billionaire, and I forget how he made his money, but it actually didn't have anything to do with space particularly. But he's really interested in it. He's really interested in jet aircraft, and he owns a number of supersonic jet aircraft, which he likes to fly around, but he loves space. So he had basically purchased a number of flights on the Dragon spacecraft from SpaceX and Elon Musk. And he has gone into space twice on these flights that he's bankrolled, and he's basically found crew to go with him. And it was interesting, like he for his first crew, he chose somebody who had actually been treated for cancer and recovered from it, and just a couple of interesting people, but not necessarily who you would think of as astronauts. And that flight, which took place a couple of years ago, got a lot of interest, and then a year and a half ago, he flew again, and he actually performed an extravehicular activity. So he was the first person to do an extravehicular activity from kind of a non-governmental flight, um, and he actually has booked some more flights from SpaceX. Now, because of that, he's been associated with Elon Musk and SpaceX because he purchased these things from SpaceX. And while I'm sure he does get along with Musk, I'm not sure whether they're super big friends or whether they see things the same way. And throughout his time as the possible NASA administrator, he has, and this is rare for a Trump nominee, had support from people on both sides of the political aisle in the United States, and still does today. So that's a big development that he is coming back, and so we will see. Now, while he was between nominations, he actually wrote up a little report which he called Project Athena, which was kept hush hush until a week ago, and then it was leaked to the media, probably by someone who would have been happier with, say, Sean Duffy become permanent NASA administrator rather than Isaacman. But what does this talk about? And it's kind of the way forward for NASA. This year, as I've talked about in some of my talks, NASA has undergone massive cuts. Roughly a quarter of its staff have left. 20 to 25% left or retired or whatever. And there's just been kind of mindless cutting going on. As some of it to do for just the joy of cutting things, and some of it because of political reasons. For example, the Goddard Space Flight Center, which is where Hubble is controlled, is also the place where they do a lot of Earth science at NASA. And of course, they get into things like climate change, which isn't very popular with the Trump people. So those people are being cut. This is the current team. Sean Duffy, who I've talked about a little bit, and Amit Kastreya, who actually is a scientist. So I think he is kind of the adult in the room in some of this stuff. This fellow here is the person who's been administering what I would call the mindless cuts at NASA. He is one of the main architects of the Project 2025, which is a kind of a very right-wing thing, cutting government. He's known to be very anti-science, shall we say, and so other things have been cut, like the Weather Bureau and all sorts of other things. And he was kind of in the driver's seat over the summer, and then of course during the shutdown, everything has kind of come to a halt, and so we will see what happens after the shutdown is over. But anyway, I don't want to go further into a lot of the political stuff that's been going on, except where it fits in with what's going to happen in the future. So one thing that that Sean Duffy has been doing is it's very important to him that and obviously to a lot of people in in the government, both inside and outside the Trump administration, is that the next uh, voice we hear from the surface of the moon is America. And but the Chinese have been very aggressively working on advancing their lunar program. At present, they have taikonauts in space in their own space station, and they've landed a vehicle on the far side of the moon, and it sent back images and things like that. But they've been quite open about the fact that they're developing a spacecraft to land taikonauts on the moon. So the plans of the United States was, of course, we've got Artemis 1, which flew a couple of years ago, didn't have anybody on board. Artemis 2 has 4 people on board, one of them Canadian, Jeremy Hansen, and they are going to be taking a rather complicated trajectory around the moon. The work on Artemis 2 has been progressing quite well because it's using roughly the same equipment as Artemis 1. And it's Artemis 2 could be going as soon as the beginning of February. At one point they were talking about April, but they seem to be February seems to be more feasible. And for example, in December we're going to be having some of the the mock countdown things that they do before they actually launch things, which is a real sign of progress. So Artemis 2 is in pretty good shape, it appears, but where's Artemis 3? So for a long time they were talking about, oh, it's going to be 2024 and then 2025. At present, they're still saying 2026, but a lot of people are saying, "Oh, come on, it's going to take more than that," because Artemis 3 is supposed to land people on the moon, and so this is where there is some controversy going on, and so we're gonna see what happens. So the former chief of NASA in this case is actually a guy named Jim Bridenstine, who is the administrator of NASA during the first Trump administration, and well, sort of a Republican from Oklahoma, but he is thought of to have done a credible job as administrator. I have no criticism to offer of what happened with NASA during the first Trump administration. And so anyway, this fellow, Bridenstine, said, I'm really worried that we're going to lose, that the Chinese are going to get to the moon before Artemis does. And then Sean Duffy started saying things like that. And so this has attracted some attention from Elon Musk, who has hit back in his typical understated fashion, shall we say. So the kind of the heart of the question is the lander. So on the left in this slide, we have the lander that SpaceX is working on uh, for the landing, and it's very similar to their big super rocket that they've been launching lately. And of course, it looks very much like something you would see from a 1950s sci-fi movie. It's a lot bigger than the lunar module that we know and love from Apollo. You can see, up here. This is the cabin where the astronauts are, and there's a lot of fuel, and they have to basically get down from up here to the surface. There's also the question of, is this thing going to tip over? um, and so this was awarded as the prime contract to build the lunar landing vehicle for Artemis 3. But there's been very little said about it. There's been, Musk has been testing the Starship. And of course, earlier in the year, they had a string of failures of the Starship, but the last two have been successful. This is one of them coming back to Earth. They just splashed it down. The first stage was recovered, but they just let the second stage recovered. But this was after a couple of things where it blew up in space. So and the starships have not been in this configuration for a lunar landing, and it's all been kept hush hush, and this has contributed to the speculation that Musk is so focused on Mars, getting Starship to Mars, that he's been neglecting the Starship vehicle to get to the moon. So in the face of all this discussion from people like Bridenstine and Sean Duffy, SpaceX has been revealing a bit more about their work with this lunar lander, and I've just been seeing films on TV. There's quite an active community of people who are into space, and they do these YouTube videos that I watch a fair bit. So we're beginning to hear a bit more, but Musk is lashing back at Duffy and people like that. How dare they? So what's at the right? So this is the vehicle that is being developed by Blue Origin, which is the firm that Jeff Bezos of Amazon has started. So basically, Duffy, who, pending the resolution of Isaacman's nomination, is still in charge of NASA, as far as I know, is that, he's opening up the competition again to others, which basically means Blue Origin. So this is one of the spacecraft, and probably the main one for Artemis, that Blue Origin has been working on. So and it's actually a lot smaller than the vehicle that SpaceX is proposing. You have a bit of a sense of the scale, and they've put the astronauts at the bottom under all the fuel and all that stuff, rather than at the top, like with the SpaceX vehicle. Now, the situation with Blue Origin is a little different. they don't have quite the experience and success that SpaceX has had with their rockets. You know, the Falcon rocket is now launching amazing numbers of satellites to the dismay of people like us because of all the satellite trails. And now Starship and Blue Origin has been building these rockets like New Shepard, which takes people on suborbital hops, but they don't even have a fraction of the power of Falcon 9, let alone a Starship. But they've been working on another rocket called the New Glenn, which has a lot more power and is not comparable with the Starship just yet, but it's certainly up there with the Falcon 9s and Falcon Heavies. So they've had one successful launch a few months ago of which was not widely publicized because the payload it launched was kind of an intelligence payload, and of course it's all hush hush. Yesterday, the second New Glenn was supposed to launch with vehicles going to Mars, the Esplanade, I think they're called. And that launch was scrubbed due to weather. But that, the success of that launch will be kind of vital to how Blue Origin is seen in terms of building this lunar spacecraft. It's known that that Blue Origin has been, even though NASA decided not to go with it a few years ago, that they have been working on it and putting resources into this spacecraft. So this is kind of essentially the situation we're looking at for Artemis 3. Are they going to let SpaceX go with it, or are they going to go with competition? And it's a little hard to tell, but if nobody believes that there's going to be any Artemis 3 in 2026, and even 2027 is going to be a challenge. The question is who can get to the moon before 2030? And there's a lot of money coming down in China. Now, Jeff also mentioned things like the Lunar Gateway, which is a station that would orbit the moon and would be kind of a way station for Artemis, for say future Artemis spacecraft, which would launch in an Orion spacecraft similar to what we have with Artemis 2, and then transfer to the one of the spacecraft as you see in this slide. Now this has to do, and this is going to be an interesting political question in a sense, because in the original round of cutting that was going on earlier this year, a lot of the Artemis program was thrown into question, and the Lunar Gateway was actually canceled. And then you might recall at the beginning of the summer, the big thing that was going on in Washington was the so-called Big Beautiful Bill, which was ultimately passed by Congress. And it wasn't the budget bill, but it had budgetary implications. And one of them was that it basically restored funds to things like the Lunar Gateway and to Artemis and things like that. Or, sort of the advanced Artemis. Artemis 2 has always been on a solid basis. And so this gets into some of the congressional politics. So you have these new firms like new space firms like New Blue Origin and SpaceX and all that. But you also have the old firms like Lockheed Martin and Northrop Grumman and Boeing, uh, which we heard a lot about, and not in a good way because of the problems with their space liner getting to the space station. And these newer firms are able to build these vehicles for a lot lower cost than the old legacy firms like Lockheed Martin and Boeing. But the legacy firms have a lot of support in Congress because of their longtime ties to NASA, because they employ a lot of people who happen to live in generally Republican areas. Um, and uh, and also they have a lot of lobbyists in Washington. So people like Ted Cruz, who's the senator from Texas, you know what he has in his state. Um, and so they have been supporting uh, things like the Artemis program, which has a pretty heavy, at least up to now, involvement of the legacy firms, building the SLS rocket that hopefully we're going to see fly in February, and the Orion spacecraft, which will carry Jeff and his three friends. And they are involved in Lunar Gateway. So this will be a big question going forward, because if what happens if NASA if firms like SpaceX and Blue Origin kind of become the be all and end all in terms of the contractors for NASA, that will allow NASA to absorb a funding cut without having to fire all these people, because SpaceX costs a lot less than Boeing or Northrop Grumman or what have you. But it won't get much support in NASA. And this is moving to the newer space firms is something that Jared Isaacman has been talking about. He wants to, Jared Isaacman is very favorable to science. He was proposing long before anybody thought he'd be, he was, Trump got back in and he was in the table to be administrator. He was already saying, well, I'll help bankroll another rescue mission for Hubble using a Dragon spacecraft, things like that. He likes science. But his plan would be to allow cuts to NASA, but mainly at the expense of these big legacy firms. And I'm not sure whether that's politically feasible. So I think that's kind of the lay of the land where things are right now. So the next few months we can look forward to the Artemis 2 flight. And then we will see what happens with Jared Isaacman becoming NASA administrator, and how he proceeds with the varying views of how programs like Artemis should go forward. And maybe I'll leave it there. So does that help you a little bit?
Well, that was wonderful review. Thank you. I mean, everything these days, especially involving the states, seems to be complex and political.
Yeah, but yeah, there is a bit of a hope that just some of the terrible politics that's been afflicting the states might go away from NASA, but we have to see, and it's an important it's an important thing to see how these different firms make out, because they're kind of built on a different models from each other, and probably I tend to support the commercialization and the newer firms because I think that's probably the best way to continue the reach into space. But it's kind of a mixed bag for the politics, regardless of which party you're with down there. And anyway, one thing I should mention is the 2030 thing. Of course, another deadline is 2029, which theoretically is the last day that President Trump will be in office, unless he figures out a way to get another term. And they would very much like to have the Americans back on the moon while he is still president.
Interesting. Hopefully that doesn't run up risks. So any questions for Chris? Anybody?
Reg? Chris, the Artemis lander there.
Yeah.
I might be wrong, but the scale of it isn't the height of a 17-story building, I believe. It's
very tall. Yeah, those two images I have there are very different scales. I wish it had a say somebody walking next to it, but yeah, these are very different vehicles.
And it has an elevator to lower the astronauts down from the kind of the red mark on the side.
That's right.
The surface.
And it's such a big spacecraft, the Starship, like that stage has to be used to help get the thing into orbit, and then just into orbit around the Earth, and then it's sitting there without any fuel in it, and then they have to refuel it, and the refueling has not been even tested in space yet. Although I was watching one of these shows last night, these YouTube shows, and they were saying, well, they're actually doing a lot of testing on Earth, but they have to do some testing in space. And this is another thing that's got people concerned about the SpaceX situation and why they're looking to Blue Origin, even though in a lot of ways they're unproven.
So, Chris, one of my concerns is two of the recent missions, there were private missions that made it to the lunar surface and landed without crashing. Two of them in a row have fallen over.
Yes, that's right. And this has not helped Elon Musk with his case. Of course, it's probably a little different when you have humans at the control there, but we still have to find out more about it. So yes, that's a big concern.
That's one.
It doesn't take a rocket science to figure it out. Well, maybe it does.
Chris, are you able to take down your screen share? Please?
Yes.
Thanks very much, Chris. I'm gonna just move forward if there aren't other questions. In 2006, New Horizons launched. It was a craft that was designed to study the outer planets, go by Pluto, and then go up to the Kuiper Belt. 10 years ago, it did a flyby of Pluto. Phil Stooke had a little bit of a presentation about that flyby.
Yes, we're just setting it up here.
Thank you.
All right. Yes. Thank you. So I'm calling this Pluto and Neighbors because at the end of it, I want to look at some of Pluto's neighbors in the Kuiper Belt, which would also make very, very interesting targets if a spacecraft gets out there again. So, oh yeah, there we go. Let's start off with what we knew about Pluto before New Horizons, and really it was the Hubble Space Telescope that was giving us most details, although there were other sources of information like occultations. However, if you Google Hubble Space Telescope map of Pluto, you'll probably see pictures like these. The actual images are across the top there, and a sort of estimate of what pattern of markings it would take to reproduce those images is created and then wrapped around a sphere to make those maps below. And that was what we knew about Pluto before New Horizons arrived. It's a very high contrast world. It's got dark spots, it's got bright spots, complicated pattern of light and dark markings. But other than that, you don't know anything about it. We don't know if there are going to be craters there or anything else like that. This was the best that could be done. However, that middle view, 180 degrees longitude, it's labeled as there, that middle view with the very bright spot and then darker material on each side of it, was thought to be the most interesting area to look at close up. So the timing of the New Horizons flyby was set so that they would see that view as they flew by. And sure enough, they did. There's Pluto, the lower right, and its moon. The moon has a Greek name, and if we were speaking Greek, we would call it Charon, but a lot of people call it Sharon because of the way it's spelled. So there it is anyway. It's about half the size of Pluto. Pluto is about 2,400 kilometers across, and its moon is about 1,100 kilometers across. And as you see, this very high contrast surface. The colors there are greatly exaggerated. The colors in the first picture that I showed were roughly true colors, slightly reddish with prominent dark and bright areas on each side of it. But we can see it's obviously quite a complicated surface, and the more you zoom in, the more complicated it gets. So let's start zooming in a wee bit here. That big bright area turns out to be a nitrogen glacier. The atmosphere of Pluto is mostly nitrogen. It's very, very thin because a lot of it is condensed out onto the surface, it's so called. And so these white areas are nitrogen glaciers filling in a big depression. We think the depression was a huge impact crater, about 1,000 kilometers across. And it's been completely filled in with nitrogen ice. And then we see nitrogen frost in other areas around it. So this is a very cold place. There are all sorts of other things there, methane, ammonia, carbon dioxide, carbon monoxide, and so on. Lots of other things that we think of as gases. But all of them are frozen because it's so cold. And they freeze in different places, and you get different markings partly because of that. And the dark red stuff is carbon compounds that are they're created out of stuff like methane and carbon dioxide by ultraviolet radiation, and they tend to have a reddish color. So that's what that's coming from. This is a close-up in part of the darker area. There are lots of craters, but if you are used to looking at the moon, you know that in the highlands of the moon, it's literally wall-to-wall craters, craters overlapping other craters, which are overlapping other craters, just wall-to-wall. And here, there aren't so many craters. There are spaces between them. And there are other things happening, big fractures in the surface and so on. It's a world that's had some geological activity. And people weren't really sure whether to expect this or not, because Pluto is quite small, and you need an energy source to drive geological activity like this, to fracture the crust and make flows on the surface. So,
Cleats.
yeah, yeah. Right. Yes. So plenty of craters there anyway, but it's not wall-to-wall craters like the moon. It's a world that's seen some geological activity. Here's another part of it. These colors are not true colors. This is what you get when you start mixing in different infrared wavelengths and you have to represent them as some kind of color to see them. So the colors don't really mean very much, but they're showing areas of different composition. It's a complicated surface. Parts of it look like they're eroded, perhaps by cycles of freezing and thawing. And with all the different materials there, they can freeze and thaw at different temperatures and do all sorts of different things to the surface. So it's a complicated place. And then at the bottom of the view, there's an area that's sort of creamy colored with some brownish spots. And that's back in the bright area that we were looking at before. We'll zoom in a bit closer. I've cranked up the contrast so we can see subtle markings inside that bright area now. But that's just, the big nitrogen glacier. It looks like it might have convection cells in it, as if in the depth of, say, several kilometers of nitrogen ice, it's convecting. So slightly warmer areas are rising, and then they fold over and sink back down in another place, and it produces patterns like these. A complicated place. Here's an even closer view right at the edge, looking at the mountains on the rim of that big depression, and then the nitrogen ice with its kind of convection cells, which are the big polygons, and then surfaces with all sorts of little pits and hollows and other patterns elsewhere on it. It's clearly been very active. Very, very unusual place.
It's just a liquid or a fluid rather than ice. Convection cells.
Well, ice will slowly convect.
Water ice will.
Yes, and so well, nitrogen ice will on Pluto.
Will it?
Yeah. Yeah, that's what they think anyway. So people have given names to these features, of course, and they're quite a mixed bag of names. Tombow Regio there is the bright spot, the heart-shaped bright spot, and that's named after Clyde Tombaugh, who discovered Pluto. You can see a lot of names. Some of these names are associated with astronomers who've studied Pluto and other people associated with it. Up at the top left is the name Burney, for Virginia Burney, who's the young girl who suggested the name Pluto.
Oh, right.
Yeah. And we also see names for various kinds of space missions to other places in the solar system. So the big white patch is called Sputnik Planitia, or Sputnik Plane. And we can see Voyager, Terra, Pioneer. Hayabusa was a Japanese asteroid mission there. So quite a mixed bag of names, but people do like giving names to things. And Pluto does have a very thin atmosphere, but quite a complicated atmosphere. You can see here, the spacecraft is just flown past Pluto, and it's turned around and it's looking back at part of the crescent. Now, if you imagine extending that out to each side, you're looking at a narrow crescent of Pluto. And the atmosphere has multiple layers of haze in it, even though it's so extraordinarily thin, only about 1/10,000th of the density of Earth's atmosphere at the surface. But it's very, very thin, but it has some structure. And actually there was enough atmosphere to scatter light into the shadows in some of these areas. And this processing doesn't show, but you can see details in the shadows there because of scattered light through that thin atmosphere, even though the atmosphere is so thin and we're so far from the sun. So quite remarkable, really. And it's just an amazing landscape. You can see the mountains casting shadows towards the terminator. If you look closely right at the limb at the top, you can see mountains in silhouette against the atmosphere behind it. Quite an amazing landscape. Here's the big moon, Charon or Sharon, which has also had all sorts of geological activity going on it. It's got craters on it, but it's not wall-to-wall craters. The density of craters in that lower part is more like the density of craters on the lunar seas or mare surfaces, like the Sea of Tranquility. And so it suggests the older surface has been covered up with something younger, and then the craters have accumulated on top of it over the last, say, 3 billion years or so. That red stuff at the North Pole is similar to the red stuff on Pluto, and some people have suggesting that it's come from Pluto, that red material in the atmosphere is swept away by the solar wind and escapes Pluto's low gravity and accumulates on the shower. And I'm not sure why it would be concentrated at the North Pole there, but it apparently is. So very, very interesting place. There were some little moons too. There's the limb or edge of Charon across the bottom there, and the 4 little moons to scale. 2 of them were discovered using the Hubble Space Telescope, the larger ones. The other 2 were discovered by New Horizons on its way in, and they didn't get a chance to see them close up. But as usual with small objects, they have irregular shapes because they've just been bashed around by impacts. But they're quite an interesting bunch of little moons with strange resonances between their orbits and the way they rotate and things like that. Quite complicated. But I want to just close off by looking at a few of Pluto's neighbors.
Can I have a question before that?
Yeah.
Do the moons travel in the ecliptic?
No, they don't. They travel in Pluto's equatorial plane. Yeah, which is very steeply inclined to the ecliptic, about 60 degrees inclined to the ecliptic. So people do sometimes wonder if we might go back to Pluto because it turned out to be so interesting. And people have talked about a Pluto orbiter, but that's not the highest priority in people looking ahead at things. But I think if something were to go back into the Kuiper belt there, that there are actually plenty of other objects that are interesting enough to want to look at. Here's a few of them. This graphic was made when we only knew about 2 of the moons of Pluto, 2 of the little moons, and not the very tiny little moons that were discovered on the way in by New Horizons. So it just shows the larger moon and 2 little moons there for Pluto. But several of the other objects have moons, as you can see. And actually, the more we look at these things, the more moons we find. There's also a lot of variation in color and albedo, the brightness and darkness of the surfaces. So these are very varied worlds. When this graphic was made also, Eris, the one at the top left, was thought to be just slightly larger than Pluto, and that was why Pluto got demoted. But then we discovered that Eris is actually just slightly smaller than Pluto, but not small enough that they decided to reinstate Pluto as a planet. But these things are semantics. Let's have a look at 1 or 2 of these worlds. So Eris itself, very slightly smaller than Pluto, but about the same size, a bright surface, which actually suggests it's got some kind of activity on the surface that is making it bright. Continually exposing fresh ice, and it might be similar to Pluto in its geology in that respect. It's got a moon called Dysnomia, and it's mostly further out from the sun. It's entirely further out than Neptune, and mostly further out than Pluto, as you can see there. And it seems to be covered with methane ice. Here's Makemake. It's another of these objects. It has a moon, apparently a very thin methane atmosphere. And infrared observations show that it might have a warm spot. Now, this is warm in terms of the outer solar system. So, it might only be minus 170 degrees instead of 180 or something like that. But it's slightly warmer than the surroundings. And that might be a sign of internal activity too. And this is one of the most bizarre of these objects. Lots of things in the solar system have irregular shapes, non-spherical shapes, but they tend to be small. And if you look, for instance, at the moons of Saturn, the biggest non-spherical moon is 350 kilometers long, about 200 kilometers across. This is 2,000 kilometers long, 1,000 across at the middle. It's by far the biggest non-spherical object in the solar system. And we don't really know why that is. It seems to have a red spot at one end, similar to the red stuff on Pluto and also seen elsewhere. But that is only the beginning of the weird things about this world. It's got a ring. We know it has a ring because of occultations. People like to see occultations of these things. They move in front of us as background star. And as you watch, the star will suddenly flicker off because this thing's moved in front of it, then flicker back on when this thing has moved aside. And you get an estimate of the diameter along that chord that you've measured there. And if you can get multiple observations of the same occultation, you can map out the shape of it. And that's how we know that it's elongated. But if you start taking your occultation measurements a little bit earlier, you might get lucky and see something else block starlight very briefly. And that's what happened here. A star flickered off very briefly, came back on, then it was cut off by Haumea itself, then it came back on, then it was cut off by the ring again on the other side. So there's a ring all the way around it, and it's been probed by several occultations now. Who would have thought that there would be a ring around something like this? And it also has two moons.
Yeah, you would think it would be a shepherd moon for those rings.
Well, you would, but in this case, the moons that have been discovered are too far out. So there may be shepherd moons holding that in, but they haven't been observed yet. And here's another one, Quaoar, and it's got two rings discovered in the same way, as well as one moon. And I mean, this question about shepherd moons is very interesting. The moon here that has been discovered is quite far out, and Haumea's moons are quite far out. You get those rings. Rings shouldn't really stay narrow like that because the particles collide and ricochet off each other, and the ring should spread over astronomical time periods. They should spread out. And the fact that they don't is usually because of some kind of gravitational resonance, or perhaps a shepherd moon, something orbiting very close to it, which is controlling where the particles can be. And Saturn has quite a few examples of little shepherd moons near the edge of its rings. So there may be shepherd moons here, but they haven't been observed. So there are all sorts of really interesting objects out there. And if things go back out into that area, Pluto is not the only interesting thing to look at. And there we go. That's the end of the show. There you go.
Yeah, thanks very much, Phil. That's
Yeah.
Any questions? Anybody have questions of Phil? Okay.
Brett,
Oh, sorry.
Yeah.
Go ahead.
This one, with these big telescopes coming online in Chile, the extremely large telescope, and is supposed to have all of the stuff to take away the distortions of the atmosphere, would that provide more insight into these objects, do you think?
Yeah, I do think so. I was looking very recently at new images from one of the big Southern Hemisphere telescopes using adaptive optics, imaging volcanic centers on Jupiter's moon Io, the volcanic moon, and the details are quite stunning compared with what was possible before. So they would certainly be able to do plenty for Pluto and for some of these other worlds. Yeah, so I would expect that we'd see a very considerable increase in detail on some of those things. Yeah.
Lauri?
Yes, I just wondered whether or not there's any chance that will this be on the YouTube channel, Joe? It'll go on those slides. And I'm really interested in getting some of those slides for some of the school programs. And
yeah, certainly,
we'd love to use them.
Certainly okay with me for my presentation to be uploaded as well as just the video. But yeah.
Okay, thank you. Yeah.
Shall I forward it to her?
Sure.
It's on its way, Lauri.
Brilliant.
Okay, thank you.
Thank you. There are several quite important announcements, so I want to just walk through those. Kevin, I think you wanted to say something about the upcoming program at the university.
Sure. Thank you. A great segue is the talk on Wednesdays titled Maximizing Image Resolution for Ground-Based Telescopes Using Adaptive Optics. And the presentation is being given by Dr. Van Kooten, who's a developer at the Hertzberg Astronomy and Astrophysics of the National Research Council of Canada. And that's Wednesday at 7:30 at the Bob Wright Center, Lecture Theater 104.
Which Wednesday?
This
This
Wednesday.
coming
Oh, this
Wednesday.
Wednesday.
Yes.
In 2 days. Yeah. Good. Thanks, Kevin. David, did you want to speak to the
Yeah, I'll spin off of Kevin's announcement.
Thanks.
At that particular meeting, I will also have some physical cards for the Sadu family, condolence cards. So anybody who wants to sign a real physical card, that the opportunity to do that. Also, if people can't make it and you have not signed the card and you still want to send a message, please send me a note at david@victoria.rasc.ca with your message, and I'll make sure it gets onto the card. So that's that one announcement. The other thing is we do have an upcoming sort of a swap and shop kind of situation coming up on the 24th, is it, Randy?
24th.
Yes.
On the 24th. And in the process of reviewing our situation in terms of our holdings, we definitely need to liquidate some things. So there's a number of sets of equipment coming up. We will probably talk a little bit more about them as we get closer, or I will put them up on the website. I've had them sort of assessed for their values. I mean, as they are RASC assets as opposed to our own individual assets, I have to have a feeling for what is a good market value for them, because it needs to be done in a proper way so that the money gets back to the center in an appropriate way. So I think most of the equipment's been looked at, and as I say, I do have some kind of probably like minimum values for some of the equipment, but that will show up pretty soon. There's actually two refractors. There's I think 100 millimeter refractor and then a short refractor. They're both on alt-az mounts as far as I understand. And then there is a Ioptron mini tower. It's one of those kind of like cube things. And then some eyepieces as well. So that's from David Bennett's estate. So they will be out there first. And there's also another Newtonian telescope that's potentially coming up. That's at Lauri's house right now. And I think CJ, you offered to have a look at it just to make some assessments of it as well. So you'll start seeing some of these things. I mean, that's just our first wave, but as we start to unearth the stuff at Sid's place, there'll be more things that will need to be liquidated.
David, will you be putting photos of these and descriptions up?
Yeah, we will for sure. I think Randy said that he would take some of the pictures of the Bennett estate. I know that Reg wants to sort of review that, and it may not be the sets that are going out. There's actually two sets in the Bennett estate. There's a more premium set, and then there's a more pedestrian set. They're still good eyepieces, but I think Reg wanted the opportunity to potentially refresh the VCO set. So we'll have to see what ends up, going up for sale.
Thanks. I'm going to just move quickly because we have a couple of other important announcements.
Yep,
Randy,
that's good. Thank you.
Randy, did you want to talk to the Glass Orchestra?
Okay, yes. So also I just wanted to say it would be wonderful for the next week's Astro Cafe with Reg as host to show what you might be bringing to the following week, just so that we get drive up the interest in what people might be selling. Okay, so now I'm going to share the screen, and come on, let's do that and that. Susan Grady sent me a message which I forwarded to Catherine, and just before Astro Cafe, we got this response. And so here's the deal. If people who would like to be part of that glass orchestra that she's talking about, these are going to be people that are playing wine glasses during the piece called Starlight, I believe. Then give me the name, and then you'll actually get in the program. She's hoping for at least 4 people. I've heard from a couple. And then what she said last week is you don't have to be at both of the rehearsals, but there is a rehearsal Tuesday at 7:15, and the dress rehearsal is the night before, Friday at 7. These are at St. Mary's Oak Bay. But then the most important is there's the 2 concerts, and the call is 2:30. The concert starts at 3:30, and people who are in the orchestra will sit up at the front for the first half. For the second half, you can sit where you like. And I think if you only can go to one, that would be fine, but she'd like it for you to go to both, and you get a free ticket to the concert. And then just to remind that I'm also hoping that we'll get a couple, maybe 4 people with telescopes, if it is clear, December 13 and 14, you know what it's like. But after the concert, it will be dark, and I have sussed it out, and Saturn will be easily visible, even with all the street lights. So get in contact with me for that. Okay, I will send an email with this information.
Brilliant. Thank you very much, Randy. Lauri, did you have something that you wanted to speak to?
Yes, I just have a couple of things. First of all, this coming Saturday, there is a star party up at the center of the universe for the Friends of the DAO. And it is going to be a young lady who's done some work on the history of astronomy and how the technological the change in technology has helped with how we understand some of the history and vice versa. And she's done some quite particular work, and we're really looking forward to having her give the presentation. I had it ready to share, but I won't because there's no time. But please look on the Center of the Universe website, and all the information is there. I don't know about what the weather is, but if it's going to be half decent, you're very welcome to bring up your telescopes and put things out. That would be absolutely wonderful. And we also need someone at the welcome table as well. Please talk to Melissa Tupper about whether or not you could come up and help with that. Thank you to David and to Alex, who kind of took over the welcome table on the last one. Thanks a lot for doing that. Also CJ. I think CJ also was kind of in at the end of that as well. So we really help with that. The second one is I have got the calendars, but I don't have an exact price. And I'm hesitant to kind of saying to everybody, well, it's this much money when I actually don't have the exact invoice and the shipping invoice. So I'm going to be on Wednesday night. I will be at UVic, and I will hand out calendars, and hopefully by then I will know a price, and otherwise I know where you all live, and you can I'll get you eventually. So yeah, I don't think anybody would not pay eventually when I'm doing that. So, and I will be ordering all the other things that people have asked me to. I even today I got another order for for something that came in for another one of the sky guides. So I'm hoping to make that final thing on Wednesday morning in National, and then they'll come before Christmas, but they're not here yet. So still some work to do on that. Thanks.
Thank you, Lauri. Thank you, everybody, for attending. I see that we're going to lose our time in a moment. So thanks for attending. That's great, and I guess we'll see people next week.
Thanks,
Take care.
everybody, for your presentations. Yeah.